Podcast Club. So today we are going to go over this question from 2021 Hypatia contest. The series A with term a1 to an is defined by an equals 2 to the power of n, and B is the series sequence of B is defined by b1 equals 1, b2 equals 1, and bn equals bn minus 1 plus b2 minus 1. So let's see the first question. What is the fifth term for each sequence, and that is what's the value of a5 and b5? So let's see. So a5 would be 2 to the power 5 and equals to 32. And b5 will be equal to b4 plus 2b3. And we know that b3 equals 3 and b4 is equal to 5. So b5 is equal to 11. Question B. For some real number p and q, bn equals p times an and q times negative 1 to the power of n. So what are the values? So let's try b1. That would be equal to p times a1 plus q times negative 1. And this would be equal to 1 because b1's value is 1. Therefore, and also a1's value is 2. Therefore, we can get 2p minus q equal to 1. And b2 equals p a2 plus q. And it also equals to 1. And then we get the equation 4p plus q equals 1. And with these two equations, we can solve that p equals to 1 over 3 while q equals to negative 1 over 3. C. Okay, so we can now, using the results we get in question B, and define Bn also equals to 1 over 3 times An minus 1 over 3 times negative 1 to the power of n for n greater than 1 and equal to 1. So Sn for B sequence would be equal to B1 plus B2 plus B3 and until plus Bn, which is 1/3 of A1 minus 1/3 of negative 1 plus 1/3 of A2 minus 1/3 of negative 1 times 2 to the power of 2, and until 1/3 of An minus 1/3 of negative 1 to the power of n. Rearrange this equation. What we get is 1/3 of A1 plus A2 and until An minus 1/3 of negative 1 plus negative 1 to the power of 2 until negative 1 to the power of n. These ones are 2 plus 2 to the power of 2 plus 2 to the power of 3 plus 2 to the power of n. And we can use the formula given here to calculate the sum of that sequence. So which is 2 times 1 minus 2 to the power of n over 1 minus 2. And it can be simplified to negative 2, 1 minus 2n, 2 to the power of n. And next, we can consider these ones. So this whole bunch of stuff could only be negative 1 or 0. Because this is negative 1, 1, negative 1, 1, negative 1, 1. And when there are even number of terms, so which means when n is even, the sum of these is 0. And when n is odd number, the sum of this is negative 1. So there are only two situations, which is when n is odd the sum of b is 2/3 times 2 to the power of n times 2n minus 1. And when n, this is when n is even. And when n is odd, the sum is same here, but you need to plus 1 over 3. Okay, now the question asks, determine the smallest integer n that satisfies Sn greater than 16 to the power of 2021. So 16 to the power of 2021 would be, because 6 is 2 to the power of 4, so this is also can be written as 2 to the power of 4 to the power of 2021, which is 2 to the power of 1884. And now, because we know that the sum of the B sequences need to be greater than 2 to the power of 8084, and it can be even written as 2 over 3 2 to the power of n minus 2 over 3. That would be greater than 2 to the power of 8084. And now we time both sides with 3. So it's 2 times 2 to the power of n minus 2 greater than 3 times 2 to the power of 8084. So because n must be very, very big, so we can actually ignore the negative 2 here because it is very insignificant. So we need to make sure 2 times 2 to the power of n is greater than 3 times 2 to the power of 8084. Because 3 times 2 to the power of 8084 must be greater than 2 times 2 to the power of 8084, which is 2 times 2 to the power of 8085. Therefore, that means 2m to the power of n plus 1 must be greater than 2 to the power of 86. That means m must be equal to 86. So it means n equals to 85. Also for this equation, because it's only the difference between these two equations are only 1/3, but 1/3 is very insignificant compared to when the n like 2 to the power of 85 or 84, so we can actually ignore that. Therefore, the answer to this question is n equals to 85. Okay, thank you. I hope you understand all of it. This question is not so hard, and I hope you are doing well on the Hypatia contest.